Our first guest speaker is Dr. Yuisong Gang, who did his PhD in pesticide science. It's a privilege and honor to have you with us today, Professor Dr. Gang. Dr. Gang is an associate professor at the School of History, Geography and Tourism, Chengdu Normal University. Prior to that, he was a postdoctoral fellow at the Institute of Agricultural Resources and Regional Planning at the Chinese Academy of Agriculture Sciences, and a visiting scholar at the University of New Hampshire. Dr. Gang also holds an administrative post of laboratory chief. Uh, Regarding his scientific achievements, Dr. Gang is mainly engaged in the field of agricultural non-point source pollution control, agricultural waste resource utilization, greenhouse gas emission reduction, and circular agriculture. In 2020, Dr. Gang won third prize for science and technology progress for research and application of soil environmental quality assessment and efficient utilization of water and fertilizer in the production area of goji berries. In 2017, he won the second prize of National Science and Technology Progress Award for his work on establishment and application of a national monitoring technology system for nitrogen and phosphorus non-point source pollution in farmland. With this introductory information, may I now request Dr. Yuiseng Gang for his presentation on nutrients pollution and biodiversity. So the floor is yours, Dr. Gang. Please go ahead.
Okay, thanks, Dr. Masand. And can you hear me clearly, everybody?
Yes, we can hear you.
And thanks, Dr. Pavin, who connected me by the email recently. And I'm successful and joining this meeting by him. And thanks, Dr. Muhammad Amjad. He have been in China and finished his doctor's degree. And at the same time, I was a postdoctor there and worked with him a lot for the non-point resource pollution control. So thanks for this chance. I can share some of my research and the Chinese non-point resource pollution work. So today, please allow me to speak the title, Nitrogen and Phosphorus Loss from Agriculture Non-Point Source Pollution. PowerPoint page 2 is how the nitrogen pollution and phosphorus pollution come out from the farmland to the river. So not only land farm, plant farm, or both pet farm. When we work on the farm and produce crops, a large amount of fertilizer will be put into the field, and so here is a plane. After we use the urea fertilizer, the nitrogen will come into nitrogen or ammonia and nitrogen. And when the rainfall or irrigation happens, the nitrogen will go with the river or leaching underground to finally into the lake. And some of the nitrogen will emission in form of nitrate oxygen and ammonia, and after a distance they will fall down into the lake. So this will cause the lake pollution, especially nitrogen and phosphorus pollution. Well, agriculture nitrogen and phosphorus pollution in China is very serious. We can see this figure all around the world. Not only China is a very serious country to the nitrogen and phosphorus pollution happened. Also, Pakistan and India, our neighbors, also have the same problems. especially the nitrogen and phosphorus pollution will cause water eutrophication, and the next lot of algae will grow and they cover the surface of the water. Next step, low oxygen in the water. Next step will cause a lot of fish deaths. This kind of things happened a lot and seriously after 2000, early to this century in China. So both island lakes and coastal seas are facing serious problems across China. So there are a lot of lakes in China, but some of them have big problems, and you can see the water are all turned green. So based on these problems and the environment pollution, Chinese government have funded several projects to settle the problems. So our group have got some of the projects to prevent our environment. So the key projects by previous group in the past 10 years, we have done some work, just like the pollution control and the demonstration on regional level in watershed of Erhai Lake. And I have joined in totally for the second project. It's also about the Erhai Lake. And we want to control and monitoring how it goes, how the nitrogen and phosphorus happen and goes into the water. So modeling and control nitrogen and phosphorus load in typical catchment have been founded. Then we did some work about this monitoring works. So we use national network on nitrogen and phosphorus sets monitoring in China. So we started from 2007, and we have set 273 monitoring sites for nitrogen loss, where runoff and leaching in most of China's important places, especially almost contained all the watershed in China. You can see some of the point we cite, and the monitoring site watershed scale have been separated in 3 main areas, which was Tai Lake watershed, Xiangxi River watershed, and Erhai Lake, which it is Fengyu River watershed. And my work is focused on this Erhai Lake watershed. So after all the data collection, we have got some results in China. So we have collected all the data from 6 main areas in China, just like South Plain, Huanghaihai Plain, Huanghaihai, the red one. The nitrogen pollution is the most serious. The next is South Plain, and in northeast of China, it's not so that the pollution is not so that serious. We also have got the data shows the vegetable is the key cropping system for nitrogen and phosphorus load in a small area. But in China, the farmers use large amount and exceed the need of the vegetables on the field. So even the areas for cultivating the vegetables is small, but the nitrogen loss and phosphorus loss is larger. Also, by the data from the watershed collection, we found that the serious nitrogen and phosphorus pollution we can see it happened usually in the end or nearby the end of the outlet to the river. So 5% of the total areas in the around the outlet place, they contributed more than 10% of the totally nitrogen and totally phosphorus. Here is another example, and our data shows that if even at the same place, but if different time will cause different levels nitrogen or phosphorus pollution. We can see from 2008 to 2014, each year we have different nitrogen level, and also in the same year, different places we can get different nitrogen emission. And as we talked before, the nitrogen loss sometimes in emission gas in the gas type, and some are in the liquid type. That's the difference. That means leaching or emission. Two different types. Are in our data showed that nitrogen in the soil account for 2/3 of the loss, and the current year fertilizer account for 1/3. Yeah, and usually nitrogen leaching was closely influenced by the water input. There are two kinds of water input: rainfall or irrigation. So they have a good connection. Every time leaching, the rainfall cause leaching, or the irrigation cause leaching, or runoff will cause the large amount of nitrogen loss. So the leaching and the runoff is what we are focused on in the future research. So after we see the problems happened and we know which way it will cause, so we have found some methods to control the nitrogen loss. For now, generally we have 6 ways. 6 ways have been done, just like obtain the fertilization. We reduce chemical fertilization and use organic fertilizer and chemical fertilizer together. Research team recently. During my postdoctorate, I was in agriculture and non-partner soil pollution research group in CAAS in China. And for now, I'm in Chengdu Normal University. And most of the work done before I joined in this group is Professor Hongbin Liu, his group. We have research on nitrogen loss, phosphorus loss model, and my work was mainly about utilization of agricultural waste, just like with straw and corn manure. And for now, I'm leading a lab and project chief in this school. We also have our partners. They are professors and doctors. Dr. Qin Chuan is one of my best partners here, and we have some cooperation to do the soil research. And Dr. Chen focus on landscape and ecology. Dr. Chengrao Li focus on ecology benefit and of land use, and Dr. Lu Chen focus on the grassland ecology. And for now, we have found our new project to make the make a better environment, just like analyze rice in the rice field, production and cultivation in Sichuan region of China and major Southeast Asian countries. We have a comparison research. And we also have a research about the green gas emission control and high yield technology for rice cultivate. We also have research on soil monitoring and analyze. And we have another research on the green and fruit cultivate together this kind of farmland to manage the soil. Okay, and all the projects above was mainly from two key library. One is Center for Asian Economic and Cultural Studies at the Chengdu Normal University. It's one of our key lab in this school, in this university. Also, we want to make more cooperations with Asian countries, just like Pakistan or India, or today, everybody who joined this meeting, it's a start between, I think it will be a very good beginning to make our cooperation. And we have another P-Lab monitoring and evaluation P-library of rural and utilization. Yes. So thanks for this chance. And later I will show you my email, and please connect me if you want to explore or communicate with me. Thanks a lot. That's it.
Thank you. Thank you so much, Dr. Gang, for your thought-provoking talk on the nutrient pollution and biodiversity, and for the introduction of your team. Surely we will collaborate with you.